Hi, my name is Amit Patinkar, and I'm a member of the TensorFlow Developer Infrastructure team. Today I'll be talking to you about a couple of tutorials in TensorFlow, how to use the high-level Keras APIs, and just some general inspiration on how you can use machine learning to work on your projects. Let's get started. I just wanted to walk through a couple of TensorFlow tutorials today and maybe get your feet wet with how to use Keras, how to build a model, and do some really basic natural language processing, which is one of the more common questions we get when we go on these conference tours. So as you can see, I've pulled up one of the text classification examples we have. This is part of the tutorials that we have on the tensorflow.org page. So definitely check those out if you are interested in other things like CNNs and how to do image recognition and stuff like that. So let's get started. I'll be using Colab. Hopefully all of you are familiar with that. It's a really great tool. Definitely allows you to run Jupyter notebooks in your browser. So I'm just going to get started with the imports. We're going to be running on TensorFlow version 2.3. And we're going to be doing sentiment analysis with the IMDB database. So for those of you who are not familiar, the IMDB database is just 50,000 movie reviews in the English language. And we're going to split them up into 25K for training, 25K for testing. So I'm just going to be doing some of the potpourri of this, which is just downloading the data set. And as you can see here, we have some really nice symbols or functions for doing data preprocessing built into Keras, built into TensorFlow. So right now I'm downloading the data set. It's quite large. Just give it a moment. Right, and just doing some of the other secondary stuff there. All right, now that we've loaded the data set, we are going to set a few parameters. So I'm going to assume that you guys are a little bit familiar with machine learning. I'm not going to go too much into the nitty-gritty. So we're going to set our batch size to be 32. And we're going to run the preprocessing function here. And let's take a look at what our data set looks like. So as you can see, it's just a bunch of English strings of varying lengths. And the 0, 1 is going to correspond to whether it's a positive or negative review. So, as you can see, this is a bad review. It's 0. This is a great review. It's 1. Yeah. So there we go. And so now we're going to be splitting this into our validations and our training set. So we're going to be using 5,000 files for validation and 20,000 for the regular training set. And we're also going to make our test set as well. And here we have another small preprocessing function. We're just going to basically make all the text standardized. So we're going to strip it for quotes, new line characters, kind of make it as standardized as we can get it. And that's going to help us with training. And one of the great features in this tutorial that we've recently added is the text vectorization layer. So I don't know if any of you have seen the NLP talks we've given before, but we kind of had to do this by hand earlier. And we recently have this new layer that's really awesome that kind of vectorizes the text for you automatically. You can feed that directly into your Keras model. So we're going to do that, and I'm going to show you how that works in just a second. And Paige, feel free to jump in if you have any additional insight. I know you might know more about these new APIs than I do.
Nope, you're doing great. And right now, you might see that the Keras preprocessing layers are currently housed in something called experimental. This should change in the next TensorFlow release. But if you anything that you see marked experimental within TensorFlow is subject to change. But we're pretty confident and happy about these preprocessing layers, and you can feel free to use them in your experiments and tell us all about it.
All right, so here's kind of what the vectorized version of the review looks like. So earlier you have all all the strings, but now it's just been characterized into different integers. And the integers represent the words. But I guess what we do is of the entire vocabulary set that we have, we create a list of how often a word is used. And that word is, the lower the word, it corresponds to how popular the word is. So, you know, something like the and is are going to be relatively lower on the scale, but something like, you know, silent, I guess, is going to be rarer. So the number that you see will be a little higher. So like I said here, you know, just corresponding these integers into words. All right. And so now we're going to create the data set based on the pre-processing functions that I mentioned earlier. And now it's time to create the model. So our embedding dimension is going to be 16. And I just want to point out, and I always like doing this, how easy it is to create the model. It's literally one line of code. We're going to use the sequential API. We're going to add the embedding layer. We're going to add a dropout layer, average pooling layer, another dropout layer, and then finally the output layer. And let's see what the model looks like in the end. Around 160,000 weights. And here we're going to compile. We're going to use this binary cross entropy as our loss function. We're going to use the atom optimizer, and I'm actually not aware of what this metrics argument is. Paige, do you have any idea about that? Any chance?
Yes, so you can specify custom metrics for Keras, or just use some of the metrics that we have kind of out of the box and available in TensorFlow. So this is just defining the metric to be binary accuracy and setting a threshold. And these can often be pretty arbitrary. Mihai, GX, did you want to say anything? Or?
So the metric is used for optimizing. It's basically comparing the prediction with what you are expecting for that training set. And in this case, the binary accuracy, I think, is comparing 0 with 1. So you're expecting a string, and you get a probability above 0.8, that's a 1. To get that string, if it's 0.8, that's a 0.
All right, thanks.
Cool.
So yeah, here we're going to start our training. We're running it for 10 epochs. So slowly.
Yep. And if you want to have like a something to describe while the model's running, if you scroll up a little bit, you should see TF Data's auto tune features. Which there you go. So configuring the data set for performance. This is one of the things that I really love about TF Data, is that there are sort of optimization tricks built into your data input pipeline. So if you want to get a really nice performance boost, you can just turn on this auto tune feature. And you can also explore other tricks like caching, and then also the new feature called TF Data Service, which can parallelize data input pipelines. So that's just something to be aware of if you find that your data input processing is taking a little bit longer than you expect it to. But regardless, it works pretty nicely. And maybe the model will be done by now.
Yeah. Thank you, Paige.
Yep. Cool.
Yeah. You know, as you can see, our model is done, and we're going to run it on our test set right now. And we usually get around 86 to 87% when we do this out of the box without any optimizations or using a fairly naive natural language processing approach. So one of the really cool things about Keras is you can actually get the history of your model and actually plot really interesting metrics. So for example, your accuracy and your loss over time. I'm going to show you how to do that real quick. And one of the things I like about these tutorials is whenever I'm working on an ML problem that's relatively simple, I try to find these tutorials and I see which problem is really similar to the one I'm trying to solve. And then you can kind of reverse engineer what you want to do based on the tutorials that we have. So for example, if you're working on a really simple natural language processing problem and you want to classify something and you have your text in a tar file, everything from how we pre-process this data all the way down to this model, will give you a great kind of North Star in terms of how you kind of want to go about this process. And then once you get, a baseline model, you can start, doing more and more fine tuning and performance accuracy.
Yep, exactly. So, and to that point, it doesn't necessarily even have to be sentiment analysis. It could be any sort of binary text classification task. Like I saw a really interesting thing on Twitter the other day, where it's predicting whether news headlines were skewed right or left. And obviously if you're in the United States right now, you've seen a variety of news flash by that seems to be biased one way or the other. If you wanted to do a similar project using news headlines and their political affiliations, this would also be a pretty straightforward setup to riff on from this notebook.
Yeah. So yeah, to that point, one really interesting thing I've worked on recently was plotting the draft. I'm really into sports, so plotting the success of an NFL quarterback if he's drafted for a particular team based on their college statistics and the team's record from the previous season, stuff like that. So, and I used a simple model for binary classification as well, just to see whether they would hit like a franchise quarterback status or or like a draft bust status, and just really interesting things you can do with just basic models that we've defined here. So as you can see, we're avoiding overfitting somewhat, and these are kind of what we expect our loss in our accuracy to be after this point. And one of my favorite things now is we can export the model. So right now you're saying, what does this model really mean to me? It's like, I guess if I want to even just use it on my own like bots or like a random movie review, I'm going to have to transport it into like a vector. That's just, really messy. But we have some really great APIs that allow you to basically export the model and then, embed the text vectorization layer inside the model itself. Now, the end goal of that is earlier we were running our model on these numbers, but now you can actually run it on text strings itself. So as you can see, we can just specify some examples like this movie was great, this movie's okay, this movie's terrible, and just run it on those examples like as simple as that. And 64%, 46%, 38%. So it's kind of doing its job. And this is one of my favorite features because like I find it very hard to show someone what a model is doing outside of like actually like exporting it or and showing them directly. And if you don't have time to necessarily serve the model into your format of your choice, this is a great way to show how it works and exactly what it's doing. So yeah, I think this is all for this first tutorial. I would have normally reserved this time for questions, but I guess we don't have that right now. Is there anything anyone wants to add before I go to another small example?
So I was wondering for to speed up the feeding in processing, is that just on a single node? Is that just with like OpenMP or something like that as the backend?
Sorry, I couldn't hear the last part.
Oh, I think Paige mentioned like speeding up reading in the data. Is that just done with OpenMP in the background, just if it's multi-threading or something like that?
So for TF data service, I do believe that they do. I do believe that they do parallelization, but I'm not sure if they're using OpenMP or some other method.
Okay.
Yep, but it is. I will check into it if you're super interested. I will check into it and see if we can ask the team.
I can also probably Google how it's implemented. I'm sure it's in the documentation. Thank you.
Yep.
All right, so one last cool example I wanted to show you guys, one tutorial is style transfer. And this is a little more complex, so we're not going to go, my original plan wasn't to go into the exact creation of the model, but show you how you can use a pre-trained model to kind of get the same results and message across. So what is style transfer? So basically, imagine you have this picture of a dog. You want to impose some sort of artistic style on it. In this example, we're going to use Kandinsky's composition 7. So take something like this, And then in the end, you're going to get an image like this. And I think this is actually kind of cool. My goal is actually to apply this when I get time to do Christmas gifts. So, you know, take someone's favorite picture and their favorite artist and do something cool with that. So just going to do the beginning setup. We're going to use TensorFlow Hub in a second. And I'll show you how we're going to do that. So just downloading the images right now and just creating a function to kind of display the image. So yeah, here we go. We have that first image and we have that second image. And it's as simple as this line right here. You know, you're just going to download the, I guess in this case, we're doing the, if I remember correctly, the magenta model. And then we're just going to invoke that on the original image, the second image. And wait a second. It's going to probably do it now. Here we go. And as you can see, it's far from perfect. There are some optimizations that my original goal wasn't to get into because they're fairly complex, where you can kind of apply a smoothing function. You can you know, enhance the level of filtering that occurs on some of these minor features that kind of will smoothen the image out and kind of create it to be more similar to what we had, you know, earlier. So yeah. That's pretty much all I had right now. I guess just some other points of emphasis. If you guys are using TensorFlow and you have any questions on platform support and stuff, that's what my team kind of works on. Definitely give us open an issue on GitHub. We'll try and get back to you as soon as possible. I know we have a lot of team members that are active on Stack Overflow as well. Paige, do you have anything you want to close out with?
No, that was excellent. And thank you everyone for attending, for being excited about deep learning and machine learning and about using it for your applied tasks, as well as for your research or for your personal projects. We're all very excited about it, and it sounds like y'all are too. So if you are interested in such things, we have a program called Google Summer of Code, which if you're looking for summer internships, TensorFlow is a project where you could propose work and then get paid for it during the summer, which is kind of cool to get paid to do open source work. So be on the watch for that towards the beginning of next year. And then also, in addition to filing GitHub issues, you can also send messages to discuss@tensorflow.org. If you have any general questions, or developers at tensorflow.org, if you have any sort of more code-focused questions about the build, or about adding a particular feature, or about some of the RFCs that we've released. But we're very excited to be here today and to chat with you about all of the great work that the TensorFlow team has been doing. Yeah, just like I said, feel free to reach out if you have any questions or comments.
Yeah, and one last thing, just wanted to show where you can find the tutorials that I was just kind of working through today. Just go to tensorflow.org and go to Learn. I guess even get started with TensorFlow. And then I guess I did the ML basics with Keras and then did something else from here, but there are tons that I think you guys will all find very interesting.
Yep.
Thank you very much.